Okay, so in this last topic video for this lesson, I'm just going to go from beginning to end the process of solving one of these quadratic equations using factored form. I am going to bring in a little bit of a hint of what's to come tomorrow during class. I'm not going to spend a lot of time doing multiple examples because I think that will be a better that would be a good use of class time. Right now, I just want to kind of set the foundation for how we use what we call factored, how we use factoring to solve quadratic equations. That's how we should say it mathematically. So that being said, take a look at this example. And as you'll see, I mentioned in the last topic video that we used an example that was equal to 0. Here in this case, we have an example of an equation that's equal to 10. It's still in what we would call standard form, x squared plus 4x plus 13, just kind of written out here. Let's just take a moment to talk about the important pieces in order to solve with factored form. What is important? The first thing that you need to remember is it's absolutely necessary that the equation equals 0. So for instance, again, over here, we have this equation equal to 10. Why does it matter that it equals 0? Well, remember the whole idea of using factored form as like a sneaky way around the problem of having too many variables is because we can use the principle that we called the zero product rule, which says if we have two numbers that are being multiplied, they equal 0, we know that one or the other has to equal 0. And we're using that little bit of mathematical truth to kind of sneak our way into this problem and find a solution. But it's not going to work if the equation isn't set equal to 0. So the first thing we always need to do is check to see what this quadratic is equal to, and then fix it. Make it equal 0, which is pretty easy to do. If I want to get rid of this 10, I just subtract 10 from both sides. That's all we have to do. So don't overcomplicate it for yourselves. Just subtract whatever's over here on the left, bring it to the right, and now I have a nice quadratic on the right, and I have equal 0 on the left. Now, the second thing that's important is actually putting it into the factored form, which is going to be x plus or minus something times x plus or minus something else. That's factored form when we have a group times another group. So parentheses times another group of parentheses. Remember that we said in order to rewrite that, it's not like in other problems where the way that we're changing it is we're like multiplying the whole right side by 5 and multiply the right and left by the same thing, or we subtract like we just did 10 from both sides. We're not changing the quantity of the math here. We're actually just writing it in a different way. It's like naming, it's like if somebody wants to call me Mrs. 9 or if they want to call me Kristen, both are true ways of expressing who I am. And in the same way, right here, I have the expression shown using standard form where it's all written out. And over here, I'm looking to express it the same exact expression, but just said a different way. I'm going to say it with factored form. But of course, the big question is, how do I do that? We're going to do more of this in class, so this is just a sneak preview, but take a look at these blocks here. These are called algebra tiles, which I think I made mention to already. It's possible you've already seen them maybe in Algebra 1 before. If you haven't, no worries. We're going to kind of start from square one and talking about what they are. Now, in the last video, was it the last video or the one before, I actually drew a picture of different squares and rectangles and labeled them. What I have here right now, and actually, you know what, I'm going to rearrange this so that it looks like our equation. We just talked about the equation. Actually, let me switch back here. We're looking at the expression x squared plus 4x plus 3. That's the quadratic expression that we're considering, that we want to rewrite into this other form. here's how I'm going to represent that. Come back over. Here, this is, remember, my x squared. We're going to call this length x by x, just like in the picture. We're going to call these just 1x. So this is x by 1, x by 1, x by 1, x by 1. So they're each worth 1, 2, 3. This is worth 4 x's. So x squared plus 4 x's plus 3. 1, 2, 3. And again, that's what we have here. X squared plus 4x plus 3. In order to write it in my alternate form, I need to turn it into a rectangle, because remember, basically it's the difference between talking about area by adding up all the pieces inside versus finding area by multiplying width times length. So let's see if we can make this into a rectangle. First thing I'm going to do is line the x's up kind of like along the x sides, because they fit nice and snug right there. Keeping in mind that I want to get this to work out into a perfect rectangle, you'll add another one here. So that gives me room for another 1 square. And then look, I could put it down here, but that won't work, right? Won't make a square. I'll have a piece missing. But if I put it over here, then it all fits perfectly. And notice that I have a rectangle whose area is x squared plus 1, 2, 3, 4x plus 1, 2, 3. Or I have a rectangle that is defined by width, which is x plus 1, times x plus 1, 2, 3. So x plus 1 times x plus 3. So you can sketch that out in your notes for a moment, because now I'm going to switch over to the actual equation. Let's draw a little picture, a little representation. We had our square, 1, 2, 3 x's there, 1x down here. That's kind of not the neatest representation ever, but that works. So this was our x squared, our x's, and our 1's. And we said that this is now the same as the width is x and 1, because we're thinking about it in terms of measurement. This is the length of x plus 1. And this is the length of, that's x plus 1, 2, 3. That's, again, we're measuring like length. This is the length 1, 1, 1. So x squared plus 4x plus 3 could also be explained as width times length, or x plus 1 times x plus 3. So we did our first step, we made everything equal 0. We did our second step, which is to rewrite it in our factored form. Basically, it's width times length form. And then the last thing that we need to do, I don't have the same, well, that's kind of almost the same purple color. Yeah, that'll work. The last thing we need to do is we need to figure out what x equals to make the equation equal 0. So in other words, we know that this whole right side should equal 0. And the way that we solve for that is we say, well, if this times this equals 0, then either x plus 1 must equal 0, because then if this whole thing is 0, then 0 times x plus 3, well, that's going to make everything 0. Or this second part, x plus 3, must equal 0. Because if x plus 3 equaled 0, this would be 0 times x plus 1. That would make everything 0. So in order to make this equation true, either x plus 1 equals 0 or x plus 3 equals 0, which is now very easy to figure out what x has to equal. X must equal -1 or x must equal -3. And again, if you're not so sure, if you're not convinced that, like, if you feel like we're going way too far out on a limb here, let's go back and plug it in. If I plug in -1, -1 squared is 1, plus 4 times -1 would be -4. So 1 minus 4 is -3, plus 13 is 10. So all of that, if I plug in -1, I get 10. So that worked. Believe it or not, it actually worked. Let's see if the same thing happens for -3. So instead of -1, if I plug in -3, -3 squared will give me 9. It's plus 4 times -3, that's -12. So 9 minus 12 is -3, plus 13 is 10. So again, if I plug in -3, I get 10, and it's true. So that's how we use factored form to kind of sneakily get around the problem that there are too many variables here to solve by isolating for x. That's the way we've done it with linear equations. That's how we did it in the last lesson. However, in order to be able to talk about, to solve this particular type of quadratic equation, we need a different approach because of more than one term has a variable in it. Okay, that is it for this particular lesson. We will continue to look at how this affects our understanding of graphs of quadratic equations. We're going to talk more about that in our next lesson.